Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic mechanical engineering. We'll dive into key concepts like velocity, flow, strain, force and torque measurement. Slide 1. Velocity and flow measurement. Let's begin with understanding two key terms, velocity and flow rate. Velocity is simply the speed at which an object moves in a given direction, and it is measured in meters per second. In mechanical systems, this could refer to the velocity of a moving fluid like water or air inside a pipe. Flow rate, on the other hand, tells us how much fluid is moving through a pipe or a channel per unit of time, for example, liters per second or cubic meters per hour. Now, let's discuss some instruments used to measure these quantities. 1. A pitot tube measures the velocity of fluid by comparing the pressure difference between static and dynamic pressures. It's often used in aircraft and water pipelines. 2. A venturi meter is a device that has a converging section, a throat, and a diverging section. As fluid enters the narrow throat, the velocity increases and the pressure drops. This pressure difference helps us calculate the flow rate. 3. An orifice meter works similarly but uses a flat plate with a hole in it. It's cheaper than a venturi meter, but causes more pressure loss. 4. A turbine flow meter has a rotor placed in the flow path. As the fluid passes, it rotates the turbine. The speed of rotation is directly related to the flow rate. 5. An ultrasonic flow meter sends sound waves through the fluid. If the fluid is moving, the speed of these waves changes slightly, and that change can be used to calculate flow rate. It's a non-contact type, useful in hygienic or dirty environments. Example, in a municipal water line, a turbine flow meter may be used to measure how much water is being used daily. Significance: these measurements help in process control, detecting leakages, and ensuring that pumps and pipelines are functioning efficiently. Slide 2. Strain measurement. Now let's talk about strain, which is a measure of deformation in a material. It is calculated as the change in length divided by the original length. Since it's a ratio, it has no units. A strain gauge is the most commonly used device to measure strain. It is a small electrical sensor that changes its resistance when stretched or compressed. The amount of resistance change is very small, so we need an amplifier to boost the signal. There are different types of strain gauges. The bonded wire strain gauge is a wire glued to a surface. When the surface stretches, the wire stretches too, changing its resistance. The foil strain gauge uses a metal foil instead of wire, which gives better accuracy and durability. The gauge factor is a number that tells us how sensitive the strain gauge is to strain. It is calculated as the change in resistance divided by the strain. Strain gauges are connected in circuits called Wheatstone bridges. The quarter bridge is the simplest, using just one active strain gauge. Example, strain gauges are installed on bridges to detect stress caused by traffic loads. Significance: monitoring strain helps engineers detect material fatigue or potential failure, keeping structures and machines safe. Slide 3. Force measurement. Force is defined as a push or pull acting on an object. It is measured in newtons, N. Accurate force measurement is essential in industries for testing, safety, and quality control. The most common tool for force measurement is a load cell. A load cell is a transducer. It converts force into an electrical signal. There are several types of load cells. Hydraulic load cell: when a force is applied, it compresses a fluid inside the chamber. The resulting pressure is proportional to the force. Pneumatic load cell: it works with air pressure and is suitable where there's a risk of explosion. Strain gauge load cell: this uses strain gauges to detect the deformation caused by force. The ring-type load cell is shaped like a ring and is used for measuring compressive forces in industrial setups. Example, the digital scale you use in a grocery shop uses a strain gauge load cell. New term, calibration. This means adjusting the measuring instrument to ensure its readings are accurate. Calibration is done by comparing against a known standard. Significance: without precise force measurement, machines could be overloaded, and safety standards would be compromised. Slide 4. Torque measurement. Torque is the turning effect produced by a force applied at a distance from a pivot. It is measured in Newton meters, nanometer. Torque is especially important in machines with rotating parts like motors and engines. One of the key instruments for measuring torque is a dynamometer, which can measure both torque and power. There are rotating type and reaction type dynamometers depending on whether the shaft is in motion or not. A strain gauge torque transducer is a specialized device that detects the twisting of a shaft due to torque and converts it into an electrical signal. A torsion bar is a shaft that deforms slightly under torque. The amount of twist tells us the torque applied. In modern systems, non-contact torque sensors use telemetry or magnetic fields to measure torque without touching the rotating shaft. Rotating torque measurement is used in motors, turbines, and gearboxes. Static torque measurement is used when the system is not rotating, like in clamping devices. Example, in a car testing facility, a dynamometer is used to measure how much torque the engine can deliver at different speeds. New term, shaft coupling. This is a device that connects two rotating shafts together to transmit power and torque. Significance: monitoring torque ensures machines operate within safe limits and helps in energy efficiency and mechanical analysis.